In this lecture video, we'll talk about the cheapest link algorithm for finding a solution to a traveling salesman problem. On a typical Friday, I do like to catch up on errands when I go pick up my kids from school. Typical errands include Target, the grocery store, the post office, getting gas, along with picking up one child from preschool and another from grade school. This gives me a total of 7 locations that I need to visit, beginning and ending at my home. Of course, I'm looking for an optimal tour because I want to minimize the distance that I travel and save some time while I'm at it. Let's handle this traveling salesman problem with the cheapest link algorithm. With the cheapest link algorithm, we simply begin by scanning the entire graph and find the edge with the smallest weight. In this case, each edge is labeled with the weight of distance traveled in kilometers. And when we look over the entire graph, the smallest number we can find is 0.07 between Target and getting gas. So we want to choose this cheapest link. Now we scan the graph for the next cheapest link, or the next smallest weight. Scanning the graph, the next smallest number we find is 1.4, so we want to include this edge in our route. Repeating this process, we find the next cheapest link to be 1.8 between home and grade school. Next is 2.0 between preschool and Target. The next cheapest link is 2.7 between preschool and getting gas. However, we already have 2 edges meeting at preschool, so we cannot use another one. I'll have to skip that edge and go on to 2.8 between the gas station and the post office. Notice now that the only location we haven't visited is the grocery store. So we have no other choice but to draw in the edges between the grocery store and the post office, and the grocery store to home. Using the cheapest link algorithm, we have a route beginning at home and traveling to each vertex before coming back home. Notice that I could go in either direction. I could pick up my kids from grade school and preschool first before going to Target, get gas, the post office, the grocery store. Or I could go to the grocery store first, post office, get gas, Target, and then pick up the kids at preschool and grade school. Either direction will give me the same total distance in kilometers. This route that we calculated gives us a total distance of 24 kilometers. If we were to instead use the brute force method and find the optimal route, we'd have to do a whole lot more work, but we would find that the optimal tour is only 23.8 kilometers. Thankfully, it's not that big of a difference. But let's take a minute and calculate the relative error. Relative error is equal to the distance from our tour, 24, minus the distance of the optimal tour, 23.8, divided by the distance of the optimal tour, 23.8. This gives us 0.0084, or about 0.84%. Again, this is another method that does not guarantee an optimal route, but it does give us a great place to start and saves us a lot of time in the process. And that will conclude this lecture video on the cheapest link algorithm for calculating a solution for a traveling salesman problem.